this talk is to help you understand a little bit about the eclipses that we're having coming up very soon, and where to go and how to observe them safely. All right, so the first thing I'm going to show you is a map of the eclipses that are coming across the United States in the next year or so. And the first one is an annular eclipse, which is crossing the United States this way. And if you're in the gray zone of this one, you will see the moon try to cover up the sun, but it doesn't quite do it. So it leaves a ring of sunlight left. And because annulus means ring, that's why it's called an annular eclipse. And then 6 months later, there is a total solar eclipse coming across the United States. So this way, from Mexico through Texas and all up to the East Coast. And that will be April 8th of 2024, which is a Monday, unfortunately. So you may have to take a field trip day to get out of town. And if you're in this gray band, then you will be able to see a total solar eclipse. So only if you're in this band will you be able to see a total eclipse. And you want to be not at the edges. Anywhere in the middle 2/3 is good. But the longer the eclipse, the closer you are to the center line, the longer the eclipse will be for you. But it'll still be quite good.
In Houston, what area, what part of Houston?
At Houston, see, we're only going to be about 90% covered, a little bit more than 90%. And so it will be dark in Houston, but it won't be total. So I really, if you've never been to a total eclipse before, you want to go. And because it's one of the most dramatic and one of the most incredible things, you've ever seen. And it's not just your eyes, it's your whole experience. The temperature changes, the winds pick up, the sky gets weird, the animals start to roost. I mean, it's an eerie feeling. And then when it goes total, it's like this giant eyeball is looking at you, this white ghostly corona and this dark cutout where the moon has blocked out the sun. I mean, it's like this giant eye is looking at you from the sky, and it's very, very creepy. So if you've never done it, it's definitely worth the trip.
Did we have in 2017? That was
the 2017 went sort of came across this way, and it was total, but it was not total in Houston. It was like 75 or 80% here in Houston, something like that. So it wasn't total here then.
It was total very close to my house, though, so I was able to drive about 100 miles and see that. And I will second everything that Dr. Reiff has said. Y'all really need to go see this.
I mean, the next one that crosses Texas is in 2045, and it's just a tiny bit of the panhandle. Now, there are other eclipses other places in the world. And in 2025, I'm going to be in Egypt. But it goes across a lot of Europe. And then there's one in that goes through Spain, too. So there's more coming up. But as far as the United States is going, the next one from the United States is 2045. All right. So you want to go. All right. So here are the kind of the questions we're going to go through on this briefing. Who will be able to see it? What is it? Where do I need to go? Why do I need to go to totality? How do I observe it safely? And when is the next one? All right. So who will be able to see it? Well, there's 3 eclipses coming up. And the first one is in just a few hours. We're going to have a total lunar eclipse tonight. And for us, it will be about 4 o'clock, 4:15 in the morning, and it will end, totality will end about an hour before the moon sets. But if you are on the eastern part of the United States, the moon will set while it is still eclipsed, and that is very if you on a lunar eclipse, everybody on Earth can see it if they can see the moon. On a solar eclipse, you have to be in a specific location because the moon's shadow is very small and the moon shadow crosses across the Earth. So this was one I attempted last year in December. And what was interesting about this eclipse is that we saw it at 3:10 in the morning local time, which is weird because normally you see solar eclipses in the daylight, okay?
Yeah.
But because this was summertime in the Southern Hemisphere, we were in the region of midnight sun. So we actually had the sun was up at 3 o'clock in the morning. As it turned out, it was clouded out, but it was an interesting experience. All right, so here's the one that's coming on October of 2023, the annular, and its path. And you can get these maps from MrEclipse.com. And on our website, we have links to all of these resources. Okay, so that's the path for the annular. And then this is the path for the total. And you can get more detailed maps of these if you go to, say, GreatAmericanEclipse.com. It has really detailed maps you can go to. The other neat thing, there's a website called timeanddate.com, and you can put in your location and it will tell you all the upcoming eclipses, lunar and solar, for you. And they're really cool. All right, so here's where the solar eclipse is going to be. It starts in Mazatlan, Mexico, crosses the U.S.-Texas border on the Rio Grande, and comes across just north and west of San Antonio, just north and west of Austin. It goes through Waco, goes through Dallas. There's estimated 12 million people along the eclipse path, maybe, and probably more like 30 million that are going to be coming from elsewhere. Now, if we look in more detail at Texas, here's the path of the annular. It's going to go through at Corpus, but also Midland and Albuquerque. I actually saw an annular eclipse from Albuquerque back in 2012. So it's kind of cool that you can see it again from Albuquerque this year. I may be on the beach, and Corpus is my present plan.
I gotta run thin.
And then here's the path through Texas. As I said, the north and west of San Antonio. If you're in the center of San Antonio, you're too close to the edge. Same thing with Austin. You need to get out and away from it, but it goes pretty much straight through Waco. Okay, so what is the difference between a solar eclipse versus a lunar eclipse? Okay, so a solar eclipse is the moon casting its shadow on the Earth, and a lunar eclipse is the Earth casting its shadow on the moon.
What is it called when the sun is between the earth and the moon?
Apocalypse. I gotta get a t-shirt of that. Okay, so totality means the entire sun will be blocked by the moon, and it's only during totality that you can see the solar corona, and it's only during totality that it's safe to view the sun without eye protection. So totality, you gotta go. Okay, so here's a diagram of a lunar eclipse. And so the deepest part of the Earth's shadow is called the umbra. And people who are in the umbra will see a total solar eclipse. The sun will be completely blocked out by the Earth, okay? The people who are in the penumbra here and here, they will see a partial solar eclipse because only part of the sun will be blocked off by the Earth, okay? So when the moon is in the umbra, no sunlight can reach the moon directly. So how come is it red? How come is the moon red during a lunar eclipse?
All of Earth's sunrises and sunsets are being broadcast onto the surface of the moon.
Exactly. Okay. So this person here who is at sunrise, and this person here who's at sunset, the light that coming from the sun, the blue light is scattered out, and that's why the sky is blue, right? And what's left is red light, and that gets refracted and scattered and can light up the moon. And that's why it's brighter if it's near the edge, because it doesn't have to scatter or refract as much. It gets there easier. But it also means if there's a big volcanic eruption, so there's a lot of dust in the air, then the lunar eclipse is very, very dark, because not very much light can get through at all. Okay, so some lunar eclipses are darker than others. Okay. Now a solar eclipse, it's the moon getting in the way of the sun. Okay. Well, this is not to scale, but it's better than most diagrams that you see. The idea is the moon is 400 times smaller than the sun, but it's 400 times closer. And so, I can take my little finger and block your whole face out because I'm getting it closer to me. Okay. My finger is not as big as your face, but I can use my finger to cover up your face. Okay. Everybody do this. Okay. But if I move my finger a little too far away, then it doesn't cover up your whole face. And that's when you get an annular, is that the moon is just a little too far away. So its angular size is not quite big enough. Okay? But on average, it's not quite big enough. So we have to have the sun either we're a little bit farther from the sun, that makes the sun a little smaller, or the moon is a little closer to us, which makes it bigger in order to get total eclipses. So generally speaking, there's no more than one total eclipse in a year. There might be a total and a partial, or there might be two partials or a partial and an annular, but generally there's not more than one total in a year. Okay, so but if the moon is a little too far away, then its angular size is smaller and it can't quite cover the entire sun. So we get what's called an annular eclipse. And so the umbra, see, doesn't quite reach the Earth. There's a part called the antumbra. And if you're in the antumbra, then you see that moon doesn't quite cover up the sun. And so there's a ring of light. So sometimes people call that a ring of fire eclipse. But it is fire, which means it's not safe to look at an annular eclipse with unaided eyes. You have to have eye protection or use projection techniques. Okay, so here was the one that I saw in Albuquerque. But what was nice about that one, it was near sunset. So this was a one taken without a filter, and you can see that even though it's near sunset, it was still way too bright. You can't look at that with your naked eye. So this is kind of an overexposed what it looked like. It was still way too bright to see it without a filter. Now, if an annular eclipse occurs right at sunset, which happened for other people on that same eclipse, then you can sometimes look at it because you're using the atmosphere as your filter. Okay. So that's a case where you could look at the annular eclipse with your naked eyes, because it's the same time of day you would look at the sun with your naked eyes right at sunset. But for this eclipse, it's not going to be at sunset. It's going to be closer to noon. So you can't take a cool picture like that. It's going to be straight up. So it's going to be near clock noon for the annular. It's going to be near solar noon for the total. So both cases, it's going to be pretty high in the sky. So you're going to want to be in a nice cushy chair that you can lean back, because otherwise it's going to break your neck. Okay. All right. So what is a solar versus a lunar eclipse? And I have this little animation that I will show you. When the new moon passes exactly in front of the sun, its shadow crosses the earth. The deepest part of the shadow is called the umbra. People in the umbra see a total solar eclipse. It takes about an hour for the shadow to cross the earth. 2 weeks later, the full moon can cross into Earth's umbra. Since the earth is 4 times the diameter of the moon, the umbra is also 4 times larger, or 16 times the area. So lunar eclipses are more common than solar eclipses. Everyone on the night side of Earth can see a total lunar eclipse, but only people in the narrow strip of totality can see a total solar eclipse. So not only are lunar eclipses more common, more people can observe each one. And in fact, if there's a total solar eclipse, there's guaranteed to have at least a partial lunar eclipse 2 weeks earlier or 2 weeks later. And the converse is usually true, but not required to be true, that if there's a total lunar eclipse, then there's usually at least a partial solar eclipse 2 weeks before or 2 weeks after. Okay, does that make sense? So what is the phase of the moon during a lunar eclipse? Got to be full, right? What's the phase during a total eclipse, solar eclipse, total solar eclipse?
Has to be new.
Has to be new, yeah. All right.
So is there a solar eclipse 2 weeks past or 2 weeks from
There was a partial eclipse 2 weeks ago.
Oh, okay.
There was a partial eclipse too, and a lot of people went to it, but
When
I
was it?
well, I don't remember. Not in this
Not in our
hemisphere.
area.
Not in this hemisphere. But yes, there was 2 weeks ago, but it was just partial. Okay, so what is an annular eclipse? So here's the similar kind of geometry one for the annular. Okay. An annular eclipse happens when the moon is farther from Earth than usual. The deepest part of the shadow is called the umbra. Only if you are in the umbra can you see a total solar eclipse. Since the umbra doesn't reach the Earth, no one can see totality. And so it is not safe to view a partial or annular eclipse without eye protection. Since the moon doesn't cover the entire sun, a ring of sunlight remains. It is called annular eclipse because annulus means ring. So all of these videos you can download in flat screen or in Dome free from our website. No, this is from space.rice.edu/eclipse.
Yeah.
See, space.rice.edu/eclipse.
Yeah.
Everything I have on eclipses on that same website, and you can scroll through and see all the different things. Okay. So now let's look at what an annular eclipse would look like if you were viewing it with solar filters. This animation shows the view of an annular eclipse as seen through a safe solar filter. Sunspots may be visible on the sun's surface. The moon moves in between the Earth and the sun. At the maximum eclipse, the sun is not completely covered. And so it is never safe to view an annular eclipse directly. Always use eye protection. And since you might see one of these separately than the others, that's why there's a little bit of repetitiveness and you don't have to use my voice. Shows the view of an annular eclipse as might be seen through a handheld solar filter. Sunspots may be visible on the solar surface. Clouds may pass in front of the sun and a ring rainbow may appear. At the maximum eclipse, the sun is not completely covered. So you must always use eye protection during an annular eclipse. If you heard me say that again, I'm going to say it again. Okay. So that's the lunar eclipse. Now let's go back to what a solar eclipse would look like from the Earth's surface. Okay. So this is supposed to have audio with it. Okay, so the first contact is when the moon starts to cover the Earth. Okay, I mean, excuse me, the moon starts to cover the Sun. And then as it gets more and more covered, second contact is when totality begins. Third contact is when totality ends. And fourth contact is the end of the eclipse. Okay. And this is in real time. This is it speeded up, but it's in real time. So it's about an hour coming in. It's just a few minutes of totality. It couldn't be as short as 1 minute, or it could be as long as 6 or 7 minutes. But it's an hour going in and an hour coming out. And if you're lucky, you have 3 or 4 minutes of totality. Now, this eclipse that's coming up is 4 minutes and 20 seconds of totality. So depending on where you are, then you can get a maximum of about 4 minutes and 20 seconds. But if you're closer to the edges, then you'll get less. Okay, so what will you see when you go into totality? It turns out what you see with your naked eyes is so much richer than what you can photograph. I mean, it's amazing the difference, okay? Because this is roughly what it seems like if you've got a good pair of binoculars during totality. This is the kind of detail that is apparent to your eye. But because the inner part is so much brighter than the outer part, if you try to photograph it, you have to do a short time exposure to get the inner corona. But as you do a longer and longer time exposure to get the outer corona, then you've overexposed the inside. And so this guy does a really neat job of using computer to trace
them images.
to combine the images at low exposure and high exposure, and follows the magnetic field line. So you get that really rich, detailed image. So it's a real image. It's from real images, but it's used computerized reconstruction. And what's really cool is you can see the magnetic field lines. Okay. Now these red areas near the edges are called prominences, and they're often as loops, okay, or partial loops. And they're often loops of magnetic fields around them. You see this loop? That's a magnetic field that electrons are bouncing back and forth. So a corona looks white because it's sunlight scattered off of electrons that are trapped in the magnetic field. And so in places where the magnetic field of the sun is strong, it captures a lot of the electrons, and so it's brighter. Whereas the farther reaches, the magnetic fields aren't closed, and so there's less electrons on them, and so it's much dimmer.
As the moon covers the last bit of the sun, the sky around you gets dark. It's still not safe to remove your solar filters, though. The last piece of the sun makes a diamond ring. Bailey's beads appear, small bits of the sun peeking through valleys on the edge of the moon. Now it's safe.
Okay, so that's the beginning of totality. And when you see the diamond ring, that's when it's safe to take off your solar filters. Now, if you've got a camera, a video camera that has an LCD panel, you can take its filter off a little early, okay? Because you're not looking straight through it. But if you have an SLR where you're actually looking through the lens, then you don't want to take off your filter until it goes total. So you make sure that it's truly total before you take off your filters, because otherwise you will wreck your eyes. Okay. So now, what would you see if you are at the moon and you're looking back on the Earth? during a solar eclipse. Okay.
This sequence shows how a solar eclipse might appear from the lunar surface. Night is falling on the moon. The distant mountains are still in sunlight. After sunset, the lunar surface is blue, lit by earthshine. It's new moon at Earth, but it's full Earth at the moon. Since
the
the moon's
shadow?
shadow covers only a small part of Earth, the lunar surface doesn't get a lot darker.
Okay. So if you're on the moon, you'll see your shadow cross the Earth. Now, we have not done that from the moon yet, but once we start with the lunar colony, hopefully we'll have some of that. But we have photographed solar eclipses from Earth orbiting satellites. And so this is what what it looks like. And you notice it's not quite circular, you know.
It's fuzzy.
You'd think it would be a nice sharp edge, but because,
It's so far away.
well, not only that, see, these people are 90% covered, so it's still pretty dark shadow, okay? So and these guys are 80% covered, and those guys are 60% covered. So it's a gradation of the shadow. But as far as observing goes, it's really critical. It's whether it's total or not. It's a big difference between 99% and 100% as to whether it's safe. But there's not a big difference between 99 and 100% on that picture. Does that make sense? Okay. So here's an animation.
This shows how the moon's shadow might appear from a spacecraft in Earth orbit. This sequence is based on actual previous space-based photography. The moon's shadow isn't just a sharp dark spot, but has shading as the penumbra darkens to the umbra at the center. Since the spacecraft is in the penumbra, the sun is only partially covered by the moon.
See that up here? So the spacecraft is only seeing a partial eclipse. Okay, so not too long ago, we had 4 total lunar eclipses in a row, which was kind of cool. Again, the reason we don't have an eclipse every month is that the plane of the orbit of the Earth around the sun is not the same as the plane of the orbit of the moon around the Earth. Okay, so most months, the moon is either above the sun or below the sun. But twice a year, those 2 orbits cross each other. And so you'll have a spring eclipse season and you'll have a fall eclipse season. And those are because we're at what's called the nodes of the moon's orbit around the Earth crosses the ecliptic. Okay, so that's why there's eclipse seasons. All right, so we were lucky that we had 4 total lunar eclipses in a row. And again, some people thought that was going to be the end of the world, but it wasn't. Now, and they call it a blood moon because, you know, because the moon is very dark and very red. And here's what I was telling you about. This is still totality, but this, look how much lighter it is on this edge than that edge, even though the whole thing is still in totality. It's just closer to the edge of the umbra. Okay, now for the 2014 ones, 2 of them were selenials, which meant that the moon was setting just as the sun was rising. Well, that always happens, okay? When you've got a full moon, the full moon is in exactly the opposite direction of the sun. So the full moon will set when the sun rises, okay? But what makes a selenial special is that it's still eclipsed when it's setting. And as the sun is rising, then this red moon, okay, which is lit up from the sunlight passing over our head. We're seeing the red sun in one direction and we see the red moon in the other direction. And it's the same red light. So this is the local red light of sunrise. And then this is the scattered red light on the moon, and it's the same red because it's the same light. So this is the diagram that we did for a selenium, okay? So if you happen to be at dawn or dusk or anywhere along that line, then the sun, then the moon will be eclipsed at sunrise or sunset, depending on which side you're on. Oops, come back. Okay. And because of the refraction of the Earth's atmosphere, you can actually see a little bit beyond the horizon on either side. And you want to be up on a tall building, or especially like I find what's good is a tall parking garage because it's nice and flat. So you get up on a nice tall hill or parking garage so you can see the horizon on both sides, and you'll see the eclipsed moon setting just as the sun is rising. And so you get the red moon and the red sun within a few minutes of each other. So this time we're going to be a little not in best position for that. The best people for this would be like in New England and all along the eastern seaboard will have the best view of the selenium for this time. Okay, so here's what a lunar eclipse looks like from Earth.
A lunar eclipse as seen from Earth is leisurely, taking 3 hours or more. When the moon enters the umbra, a dark whiteout appears and grows, the partial phase. When the moon is entirely inside the umbra, totality begins and can last for an hour or more. The moon appears red because the only light reaching it is refracted through Earth's atmosphere. One side might be brighter than the other because it is closer to the edge of the umbra. When part of the moon emerges from the umbra, totality is over. When all of the moon emerges, it's the end of the eclipse.
Okay, I got another question for you. What did you notice about the shadow of the Earth on the moon versus the shadow of the moon covering the sun?
The moon covering the sun was very crisp edges, I noticed.
And what's
this
the
was-
radius? And what's the radius of curvature of that shadow? The shadow is the same size as the sun.
Right.
So the curvature of the shadow matches the curvature of the sun. Well, what happened at this one?
The moon's much smaller than the shadow.
Right. The Earth's shadow is much larger. Okay, look at the curvature there.
It's not matching.
It's not matching. And guess what? People use this to determine the fact that how far away the
distance
moon
and
was
size.
based on its size, that the moon had to be much smaller in size than the Earth because the curvature of the shadow was so much larger. Okay, now here's what you might see if you were on the moon.
In a lunar eclipse, the moon travels through the Earth's shadow. If you were on the moon, it would be a total solar eclipse for you. But the Earth appears 4 times as big as the sun. The land around you gets dark. When you are completely in Earth's shadow, the land around you is red. The only light that reaches you is red light bent by Earth's atmosphere.
You notice they don't get a really pretty eclipse because the Earth covers up so much of the sun. So you get a little bit of the corona on one side at the beginning of the eclipse, and you get a little bit of the corona on the other side.
But the atmosphere just scatters.
Is all looks
you're not gonna
red.
see you're not.
So you would see the sun, the Earth with this red ring atmosphere around it. So again, this has never actually been seen by the eyes of humans, but don't you think that would be awesome and cool to see? But look how red it gets. All right. Okay, so where do we need to go to to see it best? Well, you definitely want to go to totality, and you want to be relatively close to the center line, and, either stay overnight before and after so you can avoid the traffic, or at least be somewhere where you don't have to drive more than an hour, because traffic is going to be crazy. Now, here's what the weather forecast looks like. So this is the fraction cloud statistically. So in Mazatlan, the cloud cover is about 25%. So you got a 75% chance of seeing it. If you're in Mexico, well, here's South Texas. It's a little better than 50% chance of seeing it in South Texas, a little less than 50% in Dallas. But look, once you get up to New England, there's only a 20% chance of seeing it. There's an interesting little piece right here that's, I think, over the water. But so that's why a lot of people are going to be coming to Texas and Mexico for the 2024 eclipse, because statistically it's more likely to be clear. Now, there's a couple of ways you can find your location. If there's a website called exubier.free.france, and you can click on it and zoom in, and it'll tell you, what the circumstances will be. It's all in universal time, so you need to know that, you subtract 6 hours if we're in standard time, or you subtract 5 hours if we're in daylight savings. Okay. And so in Houston, our maximum is 94%. So it's going to get dark in Houston, but it's not going to be total. So get out of town if you can and get to the totality. And you can zoom all the way in, because it's a Google map. You can find, your exact location and click on it, and it'll tell you the circumstances. But if you use it, please donate, because it costs him every time he serves up a Google map. So donate. Now, one that's free is a great one called timeanddate.com/eclipse. And you can put in your space, and it will show you the lunar and solar eclipses that are coming to your area and the exact times. So it's a very, very nice website, and I strongly recommend it. Timeanddate.com. It's good on a lot of things too, but it's great on eclipses. All right. Why do you need to go to totality? Well, it is absolutely one of the most incredible things you've ever experienced. I mean, to me, the most beautiful things I've seen with my eyes are the aurora and a total eclipse. And they're very similar. They're both plasmas. Okay. So it's a multi-sensory experience. The temperature falls, the wind picks up, the birds roost, the shadows get really crisp and funky. The sky turns a weird shade of gray. I mean, it is just, and what's interesting, and I didn't realize until I went to a couple of them, you can have a thin cloud and you'd say, oh, it's a cloudy day. But if it's a high cirrus cloud, then as the sun gets smaller, there's less scattering off of it, and it becomes more transparent. So even a thin cirrus cloud, you can see totality. The first time that happened to me, I thought, oh my God, God just opened up a hole in the clouds just for me. And then I realized it was a real phenomenon. And it's happened to me more than once, that you think you've got a high cirrus and you're not going to be able to see it. Well, don't give up. And it is just really awe-inspiring. I mean, the hair stands up on your arms and everybody cries. The diamond rings are some of the most precious and beautiful things of the diamond rings. This one was cool because it had, you remember when I said about the ring, the rainbow around the clouds? That this was a diamond ring that had a rainbow around.
Where was that? Do you remember?
I want to say Tahiti, but I don't remember. I'll have to look at that back up.
And you can see the clouds, how beautiful.
Yeah.
It's more beautiful with a few clouds there.
Uh-huh. Now, we can make our own fake eclipses anytime now from our NASA satellites. But we watch the sun in ultraviolet to get the inner part. And then we basically kind of put a popsicle stick in front of it and to see the inner corona. And then we put a larger popsicle around it to see the outer corona. So this is a multiple instrument picture that shows the sun and one of these giant coronal loops are called the coronal mass ejection. And these can be blasted off into space. Now, what's really cool is if you're lucky, one of these can be happening during a solar eclipse. So this was a sketch of an actual solar eclipse in 1860. And this was a similar picture from that same kind of instrument back in 2013. But, and I'm sure when he showed people this sketch that he did by, hand, they all went, no, what the heck is that?
Let's see smoking.
But you can see now how he really did a good job of trying to, put down what he saw. So when it's total, everybody should have their own pair of binoculars without a filter, okay? You only need one pair of filtered binoculars. You can pass it around because it's partial forever, okay? So you can share a filtered pair of binoculars, but everybody should have their own unfiltered for totality. So when totality comes, you can look through the binoculars because it's a much better view than just with your naked eyes, because you can see more detail with a pair of binoculars. And the other thing that you'll notice is the coronal shape. If it's solar minimum, the corona is elongated along the sun's equator, but at solar maximum, it's much more symmetric. It looks more like what a little kid would draw for the sun. Well, this is going to be solar maximum, so the corona is going to be much more symmetric. And afterwards, everybody parties. Okay, so I like to take fisheye lens pictures of the eclipses. So here's one that I did in China, and I call this dragon eats sun because there's a cloud that looked like a hand that was, in fact, we had to jump in the bus and drive about 2 miles to get out from underneath that cloud. But it looks like there's sunset all the way around except right under the eclipse, because then that's in the moon's shadow. Here's another one in Australia off a boat, and this one was in Libya. Amazing. That was one of the best shadow bands I ever saw, one of the best eclipses I ever saw. This was one that the clouds were a little bit bad, but we were able to manage to see it through the clouds. Okay, so you got to do it safely. You've got to have eye protection. You need a filter both for your binoculars and for your camera. So here's some solar filters you can buy from Rainbow Symphony. They're about $20, and you can get them in various sizes to fit on the front of your binoculars or on the front of your cameras. And here's some flyers for the safety in English and in Spanish you can download. One thing that's easy to do is a pinhole projection. So you can punch a hole in the box and it makes an image of the sun on a piece of paper. And if it's a crescent, then you're in the partial eclipse. Now, if you make the hole bigger, it gets fuzzy, but you can put a pair of readers on it and sharpen up the image. So again, practice this before you go, because you want the right size box for the size of, for the readers that you get. And you can get readers at the dollar store. So the pinhole image is dimmer, but the readers is brighter and larger. And this is a fun thing to do, is punch holes in the cardboard and then take a picture of the shadow of the cardboard. And so each one of those punches then becomes its own little pinhole camera. And they did this with the Australian flag. And so this is Alpha and Beta Centauri, and that's the Southern Cross. So eclipse shades are easy, but there's no magnification. I recommend putting a pair of these filters on your binoculars. And so there's two things you need: a pair of these filters to the right size to match your binoculars, and this piece here, which is the binocular tripod adapter, which allows the binoculars to be mounted to a tripod. Well, the problem is the sun is going to be almost straight overhead. So putting them on a tripod is not going to be a good solution this time. And once you got the filters on the binoculars, you can't see anything but the sun. So finding the sun can be hard. So what you do is you put your binoculars on minimum zoom, close your eyes, put your face so your face is toward the sun and you can feel it hot on your face, and then bring the binoculars up and then open your eyes. And you should be pretty close, okay? And if somebody is near you and you're having trouble, they can kind of see how the shadow is on your face, okay? They can say, oh, you need to tip up or tip down a little bit to help find it, okay? But it's a pain literally a pain in the neck if it's nearly overhead. So you want to have a nice chair you can lean back in, one of those lounge chairs. So normally if it's not too high in the sky, a tripod is great, but this one's going to be pretty high in the sky. Now, one thing you have to be very careful of, you put the filters on the front of the telescope or binoculars, not at the back. So this guy was stupid and he put a pair of eclipse glasses on, and then he held up a pair of binoculars and he burned a hole in his filters. So you always put the filters on the front, not the back. Okay, so those are the things I recommend to get. And you can also take a pair of eclipse glasses, the cheap ones, cut them apart and tape them to the front of your binoculars with gaffer's tape. I use gaffer's tape instead of duct tape because it comes off easier without leaving a sticky residue. Now, another thing you can do is called binocular projection. And you can uncover one eye of your binocular and put again on a tripod with that same tripod adapter, but now put the image into a shaded area. And the way you align it is you try to make the shadow the smallest. When you make the shadow the smallest, you know you're looking straight into the sun. Never look through binoculars without filters on them, okay? And now if you don't have a shady place nearby, what you can do is, again, you use the shadow to make the shadow the smallest. And now here's your projected image here, okay? But it's hard to keep in the shadow. So you take a piece of cloth and wrap it around your binoculars. And so now you get a nice shaded area to see the sun through. So you can do that to see sun and sunspots any time of year. Another way is a cheap telescope. You can use it to project an image. Same thing. Get the shadow the smallest and the sun will be in the shadow, okay? But then take a cloth and wrap it around it to make a larger shadow. Okay, so everybody should have their own binoculars for totality. Now, one of my favorite ways to view the sun, especially when it's nearly straight up, is called a sun spotter. And they're not cheap. They're about $400, but they're a good investment because you can see the sun anytime. They're absolutely perfectly safe. And they're easy to align, and you can look at them and make a sketch of the sun at really any latitude and any time. So I really, really recommend those. Another thing you can use is a hydrogen alpha telescope, which just looks in the red line of the sun. And but they're a lot more expensive, and you really have to have they're really hard, tricky to align. All right, so this is me giving an outdoor demonstration on some of these. But so the idea is be close and be careful. Now there's some activities you can do, punching boards for the pinhole pictures, measure the temperatures, you put filters on a camcorder, take one of your phones and put it on video and record your reactions and the reactions of your group. Listen to yourself afterward. It's crazy. So here's a data sheet you can fill out, then the time and the temperature and the cloud cover, and if you can estimate the wind speed, and then afterwards you put in the fraction of the sun covered. So you could then do a plot of the temperature versus time and the amount of sun coverage. Okay. The other thing you do is monitor animal behavior. Did you see a bird roost? Did you see a dog roost? Did you hear, some animals chirping? Did the crickets come out? Those are the kinds of things that you can make note of. So there's a lot of fun things you can do. And even if it's cloudy, it's gonna be neat. You can still measure the temperature and winds if it's cloudy. You can still do the reading charge. You can still do the animal behavior. And, let your body experience what your eyes can't if worse comes to worse. But there is some cool science that can be done even by amateurs. They took a picture of the eclipse in two different color filters. And it turns out the two different color filters corresponded to different temperatures on the solar surface. So you could reconstruct the temperature of corona just by doing two images with two different color filters. The other thing that amateurs can do is looking at ham radio propagation, and you can see the ionosphere basically disappears when the sun doesn't shine. It recombines really fast. So these are maps taken by ham radio operators, and here's the ionospheric density. Here's solar noon, lots of ionosphere, and then boom, where the shadow is, there's just nothing. All right, when's the next one? Well, there's a couple of solar eclipses every year, a couple of, but they're not always here, okay? So here's 2024 and here's 2045. Yowie. And then there's another one here, okay? And then here are the annulars, 2048. So, you have to, they're not common, so you got to plan for them and you got to take advantage of them if they're in your. Oh, I'm not talking to you, Sari. All right. Well, there's some information on photography practice with the full moon. Be sure you can turn off the flash. Do a range of exposures. Be sure you can do manual exposures. And if you can, then you can put it together. But my recommendation is, if you are a first-time totality, just enjoy it. Let somebody else take the pictures. They will do a better job than you. What you might want to do is find a neat picture that you could do with your iPhone or with a regular camera of the eclipse with something in the foreground. If it's low on the horizon, you can even have somebody holding it. You can set up really cool pictures. But don't spend your entire totality behind a camera. Enjoy it. And if it's a clear day and you've got a good pair of binoculars, you can see that corona go really far out, which is just amazing. So enjoy it and have a great time. And we've got our tic-tac-toe eclipse game that you can download and play the game. And here's all of our information. Everything that I've shown you, and even this PowerPoint, is on our Eclipse site. So enjoy. All right. Thanks, everybody. And I will talk to you guys next week.